Welcome back to my YouTube channel. This is Justice Science Academy. Electrolysis is one of the topics that Jamb normally brings out every single year. In the course of your exams and you come across these questions, this is how you are going to solve it. With no further ado, let's get right into the video. In an electrolysis experiment, a cathode of mass 5 grams is found to weigh 5.01 grams. After a current of 5 amperes flows for 50 seconds. What is the electrochemical equivalent of the deposited substance? Option A, 0.00004 grams per coulomb. Option B, 0.00002 grams per coulomb. Option C, 0.02500 grams per coulomb. Option D, 0.0500 grams per coulomb. Now, looking at this question, the question says a cathode of mass 5 grams, but it was found to weigh 5.01 grams. So there is a change in mass. We need to get that change in mass. So let's go. The first mass is given as what? 5 grams, but when it was weighed, it gave us 5.01 grams, right? So the change in the mass is going to be 5.01 minus 5. That is 0.01 grams. Hope that is clear. Okay, so let's go. After a current of 5 amperes flows for 50 seconds, so my current I is equals to 5 amperes, right? Then the time is 50 seconds, right? So what we are going to do is to get the electrochemical equivalent simply by using the formula, and the formula is M is equals to Zi what? T, right? So let's go. We have that mass. My mass, I'm not going to use 0.01, okay? Now this is 0.01 is equals to, I'm looking for my Z, right? Multiplied by, my current is 5 and my time is 50. Is that clear? Now let's go. 0.01 is equals to, can we multiply? We have 250 Z, right? So divide both sides by 250. This cancels this, okay? Now Z is equals to 0.01 divided by 250. And when we divide, it's going to give us 0.0004 grams per coulomb, which is the same thing as saying 4 times 10 raised to the power of minus 5 grams per coulomb, right? Now, that is how we can solve this type of problem. And from what we have gotten so far, the correct option to this question is option A. During electrolysis, 2.0 gram of a metal is deposited using a current of 0.5 amperes in 3 hours. The mass of the metal which can be deposited using a current of 1.5 amperes in 1 hour is what? Option A, 3.0 grams. Option B, 2.0 grams. Option C, 0.5 grams. Option D, 1.0 grams. For us to solve this question, looking at it closely, you're going to realize that we have a mass and we have to find the second mass. And we have 2 different currents and 2 different times. So we are comparing. That means the electrochemical equivalent of these 2 elements remains the same. So let's go. M1 is given as 2.0 grams. Okay. A current of, that is I1, is equals to 0.5 amperes. Then the time T1 is equals to 3 hours. Is that clear? Now, we are asked to find the second mass, that is M2, is what we are looking for. Then the current, the second current is 1.5 amperes and the time is equals to 1 hour. So let's do comparison. Now for us to do comparison, we are going to say that, remembering that M is equals to ZIT, right? Now, if you divide both sides by current and time, we cancel out, then my M over current and time is equals to electrochemical equivalent, right? Now, because we are comparing, this becomes M1 over I1 T1 is equals to M2 over I2 T2. Is that clear? Now from the question we are looking for the new mass, which is the second mass. So making it the subject or substituting into what we have, certainly. Now we are going to have my M1 is 2 divided by my I1 is 0.5 multiplied by, okay, then my time, which is T1, is what? Is 3. Hope that is clear. Then this is equals to my M2 is what I'm looking for. Okay, now my I2, which is the second current, is 1.5 multiplied by my second time is 1. What are we going to do to make M2 the subject? By saying cross multiply. The cross multiplied M2 is equals to this multiplied by that is 2 multiplied by 1.5 multiplied by 1, then divided by 0.5 multiplied by 3. Hope that is clear. Now let's go. You know that 1.5 multiplied by 2 is same thing as 3, okay? So this is 3 multiplied by 1 divided by, let's bring it out, we have 0.5 multiplied by 3, right? Now this cancels this, okay? Okay, so we go by saying that our M2 is equals to 1 over 0.5. That is 1 over 1 divided by 0.5 is same thing as 1 over 2. 1 over 2, which will in turn give us times 2 over 1, right? That becomes my M2. So my M2 is equals to 2.0 grams. I hope that is clear. So if you have this type of question in your exam, this is how you are going to solve it, okay? So the correct option to this particular question is option B. Calculate the mass of the copper deposited during electrolysis when a current of 4 amperes passes through a copper salt for 2 hours. Electrochemical equivalent of copper is 3.3 times 10 raised to power minus 7 kilograms per coulomb. Option A, 9.5 times 10 raised to power minus 7 kilograms. Option B, 9.5 times 10 raised to power minus 3 kilograms. Option C, 2.9 times 10 raised to power minus 4 kilograms. Option D, 2.9 times 10 raised to power minus 5 kilograms. Now for us to solve this problem, we are asked to find the mass. So let's take our parameters given. Okay, from the question, the mass is what you are looking for. Now a current of 4 amperes, that is I, is equal to 4 amperes. Okay, then the time is 2 hours. We must convert this time to seconds simply by saying 2 times what? 60 to make it to be in minutes, multiply by another 60 to make it to be in what? In seconds. So what do we have? We have 7200 seconds, right? Now my electrochemical equivalent is given as 3.3 and so it's per minus 7 kilograms per coulombs. Now if you see this kilograms per coulombs, it means that your answer will be in kilograms. Is that clear? Now let's go by saying that our formula M is equals to ZIT, right? Now if you do that, what's my mass? That is what I'm looking for. Okay, what's my Z? My Z is 3.3 times 10 raised to power minus 7 multiplied by my current is 4. Okay, multiplied by, then my time is 7,200 seconds. I hope that is clear. Now by the time you multiply all through, your answer is going to be 9.5 times 10 raised to the power of minus 3 kilogram. Hope that is clear. Now this is how to solve this type of problem. So from what you have gotten so far, the correct option to this question is option B. If this video was able to help someone out there, please don't forget to subscribe to this channel and turn on the notification button to get notified each time I post videos. And lastly, do not forget to share so that other students that are preparing for this same forthcoming exam can see it and learn from there. I'll see you next time in the next one. Bye for now.